Today's lesson is going to be on polynomial functions. Okay, so what is a polynomial function? Well, we've actually we've already talked about polynomial functions a little bit. The first type of functions we talked about are linear functions. And if we remember correctly, those are of the form y equals mx plus b. We're just going to rewrite it, okay? We're going to rewrite this as y equals a sub 1x plus a sub 0, or a naught. Okay, so that was the first type of function we looked at last week, or whenever you looked at it. Okay? Quadratic functions, which we looked at in the last section. Okay, quadratic functions, those are of the form y equals ax squared plus bx plus c. Now we're just going to relabel that. So it's going to be y equals now a sub 2 x squared plus a sub 1 x plus a naught. Okay, so these terms, the a0, a1, a2, and if we're going to eventually extend this, these are called coefficients. Okay, I think I misspelled it. Okay, coefficients. So in general, a polynomial function is an expression of the form okay, y equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, now I'm going to put 3 dots, which indicates that it follows a pattern, okay? So plus, and then you're going to go down to a1x plus a0, okay? So a couple things to note. First, this is a polynomial of degree n. Okay, and this is also what we would call, just the standard form for a polynomial, okay? Second, all the powers are positive whole numbers. Okay, they all have domain. Domain is given by negative infinity to infinity. So there's no domain restrictions. You don't have to worry about division by 0 or taking the square root of a negative number here. Okay. Sorry about that. Okay. All right. Let's talk real quick about end behavior. So the leading term, let's move that down over here. The leading term, a sub n x to the n, okay, so what you sort of what you sort of want to think about is the as x gets really big, if x gets really big, either really big negative or really big positive, this term is going to dominate over everything else, okay? So eventually, you wouldn't even see all this other stuff, okay? So that's what we're talking about when we're saying the leading term, okay? And the leading term determines what we call the end behavior. Okay, so there's actually only 4 kinds of end behavior. Okay, there's only 4 kinds of end behavior. And let's list them out. So if you have y equals a sub n x to the n, okay, and n is even, and a sub n is bigger than 0, then your end behavior is going to look very similar to, say, like a quadratic. Okay, now sorry about that. Now, this isn't what the graph looks like, all right? But this is what the graph looks like if you were to zoom out just incredibly much, okay? So let's say, you drew this graph and someone has some alien civilization has a super binocular telescope and they can look, that's what they're going to see. Okay, they're not going to see all the little bumps and turns in between. We'll talk about the bumps and turns after the end behavior. Okay, second type. Well, you have y equals, it's always a n x to the n. You could also have n being even, but you could have a n being less than 0. Okay, so in this case, our end behavior is going to look similar, just pointing down. Okay, so in this case, in the second case, we say it falls to the left and right. Whereas in the first case, it rises to the left and right. By the way, I feel like I always have to put a disclaimer when I say that. I am not a particular fan of this language to describe what's going on here, but it is the language that MyLabs Plus uses. So that's why I'm using it, okay? Third, well, again, it's y equals a n x to the n. This is, again, just n behavior. If n is odd and a n is bigger than 0, running out of space, that's all right, then it's going to look very similar to, let's say, like an x cubed graph. Okay, so we might say it rises right and falls to the left. And so this explains, this example can show why I don't like this language. Because, to be honest, I like to think about increasing and decreasing as you move from left to right, okay? So I would say that this is increasing from the left and then increasing to the right. That's what I would choose as the language, but I didn't write the program. So. And finally, that's an ugly Y. Sorry about that. Y equals a sub n x to the n, where n is odd and an is less than 0. Okay, so that graph is going to look pretty similar, but the opposite of the last one. Okay, so this one will rise to the left and fall to the right. Okay, I prefer again to think of it as always being decreasing, or at least on the endpoints. Okay, all right. That's gonna sign off and start a new video on the next section, on the next stuff.